Okay, you've got a Junkyard LS. What happens when you combine carburetors, cams, and turbos? For this video, I went down to the junkyard, picked up a 5.3 liter LM7 and brought it back to West Tech. We ran a carbureted induction system and put it up on the dyno, ran it naturally aspirated. Then we added boost. Then we performed a mild cam upgrade, ran it both naturally aspirated and under boost again, like we do. There's a lot of stuff to cover here. How much was the carbureted combo worth from the junkyard up on the dyno, naturally aspirated? How much was it worth when we added boost? How much was it worth when we upgraded the cam, both naturally aspirated and under boost? Lots of stuff to cover, so let's check out that test motor and get right to the results. Our test motor was a 5.3 liter LM7, and if I remember right, I pulled this from a 2002 or 2003 pickup, brought it back to West Tech. We tried to clean it off as much as I could. We did change the ring gap on this because I knew that I would be running lots and lots of boost on this thing later on. This particular test was run on fairly low boost, so it wasn't a problem. We were not running an intercooler. It was only going to be the blow-through carburetor, but the carburetor, when you do a blow-through deal, it does lower the charge temperature quite a bit, so it was already acting kind of like an intercooler. On this combination, we ran it carbureted, so I installed an Edelbrock Victor Jr. intake manifold and a 750 Holley carburetor, and we ran the combination with the MSD ignition controller, and that worked well because we could retard the timing under boost and basically put it wherever we wanted it to be. So this combination worked well. When we ran it under boost, we installed a single turbo kit from the guys at CXRacing that included their exhaust manifolds and Y pipe and a provision for their wastegate. Although we didn't use their wastegate, we put a Turbo Smart wastegate on there because it worked a lot better. We also ran the CXRacing 76mm turbo, and as I mentioned, no intercooler. And all that combination seemed to work fairly well. We didn't run a boost, any sort of electronic boost controller. We just relied on the gate. I didn't even use a manual controller on this. We just ran it right on the spring. So everything worked out fairly well. The one change we did make when we added the turbo for both of the combinations, both the stock cam and the mild crane cam that we put on, we put a CSU 850 blow-through carburetor and then dialed the air fuel in using the combination of jetting and their adjustable power valves. So all that worked out fairly well. Now, when we did the cam upgrade, we put a fairly mild crane cam in it. I'll put the specs up here, but basically it was a 585 lift, and I think 216, 224 duration. And I'll put the LSA up here because I obviously can't remember that off the top of my head. But it was a fairly mild cam, as cams go for these LS motors. We put lots bigger ones in these 5.3s, but this one worked well. As you can see, it made a big gain. Now, I'll get lots of complaints, and I want you guys to comment about this. We didn't rev the motor very hard. I don't even think we revved it past 6,000 RPM. But it was enough for us to show the kind of differences we were looking at. And I just wanted to, and this was early on, so I just wanted to make sure that the combination would work as a carbureted blow-through deal because we didn't have a lot of experience of it when we first did this. But before we get to the results, I want to talk a little bit about distribution on this. I definitely want you guys to comment and let me know what you think about the distribution on a carbureted induction system, especially on a blow-through application. Okay guys, make sure to comment and let me know what you think about fuel distribution on a carbureted blow-through application and even on the naturally aspirated combination. I've done lots of testing on the distribution of different kinds of intake manifolds, and so I want to know how many of you guys think that a carburetor causes a problem with distribution on a typical V8. Remember, on this combination, we ran both on the Victor Jr. intake, we ran it carbureted NA, and then we also ran it as a blow-through using the CSU blow-through carburetor. But here's something to think about. A lot of guys, especially guys that are pro EFI guys, will blame the carburetor and say, oh, those things are terrible, those are toilets, those things don't distribute fuel properly. But here's something to think about. If you take a look at any of the other distribution videos, and there's a couple of them up right now on the channel, if you take a look at those, even on modern fuel injection that obviously solves everything if you listen to the fuel injection guys, there's a big problem with distribution. And it's not because individual injectors in each port can't provide exactly the same amount of fuel. They can. You can go in even and trim the cylinders individually. Usually the problem is not with what's supplying the fuel, whether that's a carburetor or the fuel injection. Usually it's a distribution problem caused by the design of the intake manifold. Even on a factory truck manifold, let's say, the airflow is different for all the cylinders. And not only that, irrespective of the airflow, the distribution is actually different. Because we know that because I've run that test. When we supply the same amount of fuel from port injection on a factory truck intake, the air fuel is different in the individual cylinders. So there's something going on, and obviously distribution is not ideal. And it's from an airflow standpoint, and maybe a reflected wave and other things that are going on. So on a single plane manifold, whether you're providing fuel from a carburetor or injectors, the distribution is different in all the cylinders. Here's something to think about. You got 4 longs on the outer sides and then 4 shorts in the centers. And so those are all tuned to make power at different RPM ranges. So if you supply the same amount of fuel, even with port injection or with the carburetor, although the carburetor self-adjusts to some extent, but if you supply the same amount of fuel, the cylinders are going to be lean and rich as those cylinders get more efficient because of the runner length provided by that manifold. So if you get distribution issues that are irrespective of the carburetor and injectors, just something to think about with the intake manifold. But I didn't do distribution tests on this. I just want you guys to think about it. Make some comments about it. Let me know what you think. Let me know if the carburetor is terrible or injection is terrible or if they both work. Let me know what you think. Let's get to the results. This is our 5.3 liter from the junkyard. We installed the Victor Jr. intake and the 750 Holley carburetor, and then the MSD ignition controller. Run up on the dyno with long tube headers. They were hooker headers. I believe this thing made 334.7 horsepower and a peak torque of 365.5 foot-pounds of torque. So it did pretty well. This is about what we expect from the carbureted stuff. The Victor Jr. actually makes a little bit less power than even the factory truck and less torque, especially down low had we run it down that low. So let's take a look and see what happened when we added our CXRacing single turbo kit with that 76mm. When we did this, we also changed to the blow-through CSU carburetor. So let's take a look at our turbo stuff with the stock cam. Here's what happened when we added boost to this cam combination. Remember, stock cam just had the Victor Jr. 5.3 liter LM7 from the junkyard. So this was a little over 9 pounds. I'll show you the boost curve later on. This is 527 horsepower. And peak torque was 520 foot-pounds of torque. So as you can see, with the blow-through carburetor, things worked out really well. We were able to dial the thing in, get the air fuel right using jetting and the boost or the adjustable power valves. So that thing worked good. Now let's take a look and see what happened when we installed the mild crane cam. Here's the power output of our naturally aspirated 5.3 with the stock cam and the carburetor on it. It made 334.7 horsepower and 365.5 foot-pounds of torque. And the reason I'm showing you this after we ran the turbo stuff is because we're going to upgrade the camshaft now. Here's what happened when we installed that crane cam, and I'll put the specs back up here as a reminder to let you know what size that cam was. So here's what happens when we installed the crane cam. Power output jumped to, I mean, those are good gains, 411 horsepower, although I don't think we were quite at the power peak yet. That's as high as we revved it, so you guys can make comments about that. And 411 horsepower and 393 foot-pounds of torque, so it did pretty well. Now let's see what happens when we install the turbo system on the one with the camshaft on it. So let's take a look at that. And just like it did when we ran it with a stock cam, the turbo added a ton of power. So we're at 611 horsepower. And as you can see, the power curve is still rising there on that combination. The boost curve was pretty flat. It was like 9.9 pounds. And with each combination, we measured the peak power output. And the power gain with the camshaft NA was about 77 horsepower measured peak to peak. With the turbo, after we installed the turbo, the gain from the camshaft was 84 horsepower peak to peak. And actually, we would expect a little bit more than that, and we'll go over that in the boost curves. We'll talk a little bit about why we didn't see maybe more of a change under boost with the camshaft. But these are the peaks and the turbo combination. Obviously, love this cam, as boost always does. This cam was a turbo cam, the stock cam was a turbo cam, and by now you guys probably know every cam is a turbo cam. So let's take a look at the boost curves provided by each combination with the stock cam and with the crane cam. We could talk about that a little bit, and then we'll get to our conclusion. Here is the boost curve of the combination equipped with the stock cam and that 76mm turbo from CXRacing. So we had a peak up here of 10.2 pounds, and down 3,500 we had 7.5 pounds. Here's what happened after we installed the crane cam. Boost curve is very similar. The only thing I want you to look at is out here past 5,400 RPM. The crane cam combination actually had a slightly lower boost pressure, 9.7, 9.8, 9.9 there. So it's down a few tenths of a pound. Now here's the interesting thing is when we ran this combination, the power difference between the NA combination was 77 horsepower between the stock cam and the crane cam when we ran it NA. Now the difference in the camshaft when we ran it with the turbo was 84 horsepower. Now we would expect a little bit bigger difference in power once we added boost, because usually it's multiplied by boost. And here's probably why that didn't work out. One is the change in boost pressure that I just showed you. With the camshaft it had a little bit less boost, but also on the camshaft, if you looked at the curve, I should have let the thing run higher. I mean, if we would have revved the thing higher than 6,000 RPM, the power was still climbing with the camshaft combo and the turbo, because we had a fairly good boost curve going on, and I think if we revved it out, we would see quite a bit more power. But on the stock combination, it was already done making power, because that factory cam just is not going to rev it even with that single plane intake. So that's probably why that happened. But as you can see, both combinations, boost curve, you know, nice curve. The turbo was working well. Combination works good. Carburetors, camshaft, and turbo. Okay, guys, what did you think? What did you think about this comparison? Putting the carbureted combo up on the dyno, running with the turbo, doing the cam swap, running with the turbo again. What do you guys think? And now I know guys are going to be disappointed, so I want to make sure that you guys comment. All the guys that want me to run to 8,000 RPM, make that comment. All the guys that want me to pin the gate, make that comment, and get it out of the way and make sure that you do it. But here's the thing with this test. I think it's important to note that it's cool to be able to go down to the wrecking yard, pick up a 5.3, and then run it carbureted. And you can do that fairly cheaply with this MSD ignition controller and a simple Holley carburetor. You don't have to run this HP or an XP or any of those carburetors. You can put a Brawler carburetor on it from Summit Racing and it works good. They're cheap, and it's a good way to go. The other thing that this test showed us is not only can you do that, but you can obviously at any time upgrade the camshaft also, and that works well. Even with the carburetor, it doesn't have to be fuel injected. LS motors love camshafts, even carbureted ones. And the other cool thing is that even with all that, you can run it carbureted, you can run it with a cam swap, still carbureted, and you can add boost. Now for this test, we put on that CXRacing turbo kit, and actually I probably wouldn't recommend that. And the reason that I don't like it is not because their stuff doesn't work, because I've used a lot of it and it works pretty good. But this particular turbo kit, I don't like the exhaust manifolds on because they're really, really close to the spark plugs. They tend to burn wires. As a matter of fact, we had to make custom wires for this kit. We had to make longer ones, and I just don't like doing that. Especially since running that kit, I've made our own using the factory truck manifolds, and those things work fantastic. They keep all the heat in, they don't burn plug wires. All we had to do is make a Y pipe. I mean, I'll never go back to anything else after doing this. All the single turbo stuff that I run almost exclusively has those truck manifolds, and they work well. So that's one thing I wouldn't recommend. The CXRacing 76mm turbo, we've used that a lot, and it works pretty well. Obviously there are better choices, but that thing was cheap and it did add boost. So you can run a Junkyard 5.3, you can run it with a carburetor, you can run it with a cam swap, and you can run it with boost. It all works. Thanks for watching, guys. Make sure to like, share, subscribe, ring the bell, do all that stuff. I'm going to keep these turbo things going. This month in January, or in January, February, March. In March, I'm going to be adding a bunch of new stuff to the channel. We're going to be doing a ton of LS stuff, but I'm also adding almost every other engine family, because LS stuff isn't the only stuff that I've tested. I've done modular Fords and Coyotes and Hemis and big blocks and small blocks, you name it, and I've tested it. So I'm going to be integrating those in, but don't worry, plenty of LS stuff also. Thanks for watching.